Hello Geometry Superstars, this is Mr. Anderson. I'm going to go over the notes packet for Unit 4 with you. This is the first day. We introduce triangles, talk about some vocabulary, and some properties of triangles. You may print this out off Blackboard and fill it in. For the first day, I want you to have the first 3 pages filled in. Here we go. Equilateral triangles are triangles where all 3 sides are equal. If you'd like to draw a picture there, it's going to look something like that. 3 congruent sides. Isosceles triangles. 2 equal sides. Looks something like this. At least 2 congruent sides. Scalene triangles, no sides are equal. 0 congruent sides. We can also classify a triangle based on its angles. An acute triangle all angles are less than 90 degrees each. And an acute triangle has acute angles. An equiangular triangle, all 3 angles are equal. These angles are all 60-degree angles. For a right triangle, one angle is 90 degrees. See if I can draw this here. And whenever you see a right triangle, you will have a symbol like that. So this has a 90-degree angle. Obtuse triangle. One angle is greater than 90 degrees. So it has one obtuse angle. Alright, now we're going to do some examples. Example 1. We have 2 sides that are congruent. This type of triangle is an isosceles triangle, and it's also an acute triangle because each of the angles is less than 90 degrees. For number 2 here, we know this symbol means a 90-degree angle. Therefore, that is a right triangle. We can also see that it's a scalene triangle. Because none of the angles are congruent. Number 3, we have 3 congruent sides, 3 congruent angles. This is an equiangular triangle and also an equilateral. Now that does it for page 1. If you go to page 2, you'll see the included angle. Here we have a triangle DEF. If we're talking about DE and F, then that's this angle here. And the sides DE, DE's here, and EF is here. So the angle between two sides is the included angle, and then the included side is the side between the two angles. So in this one here, DE is the included side of the angle DE and F, and FD and E. Some terminology. We have the vertex, and you guys have heard that term before. Let's just say the point where two segments meet. The adjacent sides, I'll just discuss in terms of this example. The adjacent sides are AC and AB. That's the adjacent sides to angle A. The side opposite of angle A is line segment BC. Here we have a triangle ABC. The vertices of this triangle are angle A, angle B, and angle C. The adjacent sides in this triangle that share, should say angle B here. The sides that share angle B are going to be AB and BC. They're the sides right next to them. So this is AB and AC. What side is opposite of angle B? Of angle B. What side is opposite of angle B? If you look here, angle B is here, and opposite is all the way across the triangle. So opposite angle B is line AC. So this is AC. Which side is opposite of angle A? Opposite of angle A is here. Opposite that is BC. And what side is opposite angle C? Is line segment AB. And in each of these examples you can see that here we want the opposite side of angle B. Well, that's AC, because angle and opposite side, you're going to have all three letters, A, B, and C. Here, opposite A, you're going to have B and C, because those are the only two letters not here. Opposite angle C, you're going to have AB. The median is a segment one endpoint is the vertex of an angle, and the other is the midpoint of the opposite side. So here's the vertex, and it goes over here. These two symbols mean that BD and DC are congruent. Therefore, D is the midpoint of that side. So that's the median. An altitude of a triangle, you're going from the vertex across to the opposite side, but this angle has to be 90 degrees. So that's the altitude. Here are the pictures for the altitude. In an acute triangle, it's going to be straight down here. There's your 90-degree angle. In a right triangle, it's actually going to be the side here because that forms a 90-degree angle. And an obtuse triangle, it's not even going to be in the triangle, it's going to be outside, forming a 90-degree angle. In this example here, we want to know if each segment is a median, an altitude, or neither. Segment AD comes from the vertex, and it comes over here to this side, and we see that there's two lines here and two lines here, which means that line segment CD is congruent to DB. Well, we know that a median comes from the vertex to the opposite side, the midpoint there. So AD is a median. What about EG? EG comes from this midpoint and goes over here to this side. That is not a median because this would have to go over here to vertex of angle B. Therefore, EG is neither. What about CF? CF comes from the vertex here and goes over to the side of AB and forms a 90-degree angle. By definition, that is an altitude. Thank you for watching. I'll see you in class.